I'm Tom Carpenter, and on today's special Hawaii edition of Power Time, we've come to Rick's house at an undisclosed location on the Hamakua coast of the Big Island of Hawaii to basically upgrade his existing power system. This is one of our long-term test sites, and this particular classic has been here for a little over 4 years. It's basically an alpha test classic, very old, and most all of its other siblings have blown up long ago, because in this case, the classic is connected to a wind turbine. It's connected to a Kestrel E300i, which is a 110 volt wind turbine. We weren't sure whether or not we needed to have a clipper or overvoltage protection device between the turbine and the classic. So this test site, we went ahead and put the clipper in. We used the Kestrel's version of it and used it to protect the classic from ever seeing over 150 volts. Well, 4 years later, we've proved that yes, if you want your clipper or your classic to survive, you need a clipper in most all cases. There are some instances where you won't, but for most all you will. In fact, Kestrel is now selling the Classic 200 as their standard controller with all their E300 wind turbines. That is their factory controller now. The other thing we're going to be doing is we're going to be decommissioning our APRS World data logger. It's what we've been using to monitor the system on our website and look at it over the internet. And we don't need that anymore because the new classic we're putting in has got all of the latest internet communications protocols built right in. It'll go right over the web for us, and not only can we monitor it with its very accurate voltage and current sensing elements that are built into it, but we also have the ability to actually control it and make changes on the fly. So it'll allow our engineers back in Arlington to be able to actually control and kind of tweak the settings on this controller and get them perfected, which we will then put into the next release of firmware. One of the things we noticed on this system is that somebody has come along and put an extra charge controller in, and they obviously didn't have a place to land their circuit breaker, so they sort of left it hanging out there in space. We're going to go ahead and upgrade that a little bit too with one of our MidNite Solar big babies. This will hold up to 4 of these little breakers. We're just going to raise this controller up and put that right underneath there, so it'll now be a code compliant and safe installation. That's what we're up to here today at Rick's house. Okay, well, we've got our classic installed and wired up now. We've now made this safe and code compliant by putting in a disconnect breaker on the charge controller. So all that we've got left here today is to go over and replace the Kestrel clipper with our MidNite Solar clipper. Okay, well, what we have here is our new MidNite Solar DC clipper, and here in the background we've got the Kestrel clipper that is used with the E300i wind turbine that we've got outside here on this system. What we're going to do here today is we're going to replace this clipper, which has done a very good job for the last 4 years in keeping the turbine from blowing up our classic, and also proving long term that a clipper and a classic together are an unbeatable combination. Without a clipper, the classic can be damaged terminally by the wind turbine. The differences between these two devices: this one is simply a voltage controller that doesn't have any external input other than the turbine. So it will just keep the voltage from rising above a certain point by clipping the turbine output to a bank of resistors inside of itself. The way that our clipper works is a bit different. It's controlled by the classic, so it allows the classic to precisely regulate the amount of power it wants to take from the wind turbine. Once the classic has got the batteries full, for example, it will throttle the turbine's output back so that the turbine will be slowed down to only give enough power to finish charging the batteries completely. And it does this by basically putting the brakes on the turbine by intermittently shorting the windings out. This not only slows the turbine down, saving wear and tear on the turbine, and lowering the noise that's output from the turbine. Some turbines actually get very, very loud. As the wind speed increases, they speed up, and the blades will get very loud, and they also tend to lose efficiency. So they're annoying the neighbors, they're fluttering themselves to death in some cases, causing damage to the turbine, and in very high winds it can actually destroy the turbine. Our clipper will prevent any of this by limiting the RPMs to a certain preset level, which is done by setting a voltage control inside the clipper. This protects your turbine and will cause it to last a lot longer because it's not spinning as fast at any given time to make the amount of energy necessary to charge your batteries. Okay, this is just a little example of why a clipper is necessary. With about 10 to 13 mile-an-hour wind right now and the Kestrel E300 freewheeling, we're getting 400, we've seen 500 volts, now 380, significantly more than any charge controller anywhere in the world could take today. So that's why we're going to go ahead and put the clipper in between to keep these lethal to the charge controller voltages from getting through to the charge controller. Okay, this is the MidNite Solar DC clipper. Very simple controls here on the front cover. You've got a stop run switch, which in the run position, obviously, it allows the turbine to do its thing. You hit it into the stop position, and it'll put the brakes on the turbine. This is important if you're ever going to open the box up. You want to stop it before you open the box because otherwise you could have lethal voltages inside. In the case of this turbine, it freewheels at upwards of 500 to 600 volts DC. That'll hurt. The other reason for this stop switch out here is, of course, during an impending storm or high wind condition, you can come out and just turn the wind turbine off so that it doesn't beat itself to death in high winds. Inside, we have the control board over here in the lower left corner, and what it basically does is provides the fail-safe function for the clipper. Should the control wire to the Classic here ever be broken or the Classic turned off for some reason or the battery's disconnected, it could allow the wind turbine to overspeed, which would overvoltage the Classic and again cause some damage. So what this does is it clips the voltage at a preset higher voltage than what the Classic is going to use, and that's this little control up here, and that simply allows you to dial the voltage up and down to get the maximum voltage it will ever allow through to the clipper, or to the Classic, I'm sorry. Down here the control wire, of course, is what comes from the auxiliary 2 output of the Classic and sends the pulse width modulated signal to this in order to tell it to go ahead and clip and take additional current and voltage that is not needed for charging and put it up into the resistor bank. The other connections on this board that you need to make are the negative output to the Classic, of course the auxiliary output. Then over here you've got a terminal block that has the positive output to the Classic and then the positive and negative inputs from the turbine. Over here on the back of the door, this is just the back of the stop switch circuit breakers that either open or short the turbine. And then up above that, we've got a big solid-state bridge rectifier and a solid-state relay. And the solid-state relay is what the control board uses to control the amount of current being sent over here to the resistor bank, which is behind this metal case here. And of course, you've got a fan on the bottom so that if you've got extremely high winds, your batteries are full, it'll go ahead and cool the resistors off and dump off the extra power that you're not needed. Okay, well, we've got everything hooked up and ready to go. We've even got some wind. So what we're going to do now is we're going to show you how to program the Classic to work with the DC clipper. Okay, well, to set the Classic up to work with a clipper, you simply go to the main menu and then scroll over to Mode, hit Enter, right arrow over to Wind Track, then you press the right soft arrow, which is under the word Graph, and then Memory. Then what you're going to do is you're going to scroll up through the memories until you find the wind turbine that we're using here. That's a Berge XL1. We continue on. There's a Kestrel 110. There's the Kestrel E300i, 110 volt, and this is a 24 volt battery. So that's the one we want. What we're going to do is we're going to go ahead and save that. And then you simply scroll back down through the then you go to Memory, scroll back down through the memories until you get to the memory location you want to use to run this one. I always use memory location 4 for mine. So you simply save it to that memory, press Enter, that writes it to the controller, then you can simply go back to your status menu. The other thing you're going to want to program is the auxiliary output. So again, from your main menu, you go to Auxiliary, Enter, go over to Clipper Control, and then right soft key, Setup. And so we're clipper control, PWM control for clipper. You're going to set volts now. You don't worry about these volts and width. Those are pretty good at the factory defaults. Those are kind of for advanced setups. The important one is that the center is set for the type of clipper you're going to be using. And this is a DC clipper, so we've already got that set. And then we're just going to set the maximum voltage. And in this case, we've got a classic 150. Our Kestrel clipper has been programmed to clip at 140 volts. So we're going to go ahead and let the classic use anything up to about 138 volts to do its charging. So you just set your maximum you want, and that should be some number lower than what you've set the clipper to go ahead and clip at by itself. And so you set your voltage, hit enter, and then back to status. That's all there is to it. Okay, well, we've pretty much finished up with this system now. We've gone ahead and installed the surge protector at the base of the tower, one where the cabling enters the building, and then we've actually got a third one for the wind between the clipper and the classic. We've installed the new clipper, of course. We've got the new classic, which we want to be protected with our new SPD. We've gone ahead and put one in for his photovoltaic controllers. We've also added one on his generator input and his inverter output. That'll protect the inverters from anything coming down the power lines from the house or coming over from the generator. Now, what we've also done while we were here is we went ahead and gave Rick a battery condition monitor so that he can easily at a glance tell exactly what his battery condition is. We want to make life as easy as possible for Rick because we really like him. For MidNite Solar, this is Tom Carpenter signing off from Hawaii.